So in the notes, we talked about the definition of what a sequence is. It's just an ordered list of numbers. And in the notes, I tell you that sequences are often designated as A sub n. A sub n will define a sequence. This is very similar to the notation we learned for functions. So we saw f of x. Now if you recall how this worked, x told you what the input was, and the f of x told you what the output was. So remember, this is your input, whatever you get here, that's your output. A sequence notation is very similar, where now it doesn't say f of x, it says a sub n. This n is a subscript value, and we oftentimes read the expression as a sub n. The n tells us what the input is, and whatever we get for a sub whatever that input is, that's what the term in the sequence is. So what does that n represent in a sequence? N represents the position in the sequence. So if we see n equals 2, it means it's the second position in the sequence. So a sub 2, whatever we get for a sub 2, whatever this is, it represents what the second term of the sequence is. So if we were looking at the example like I gave you in the notes, this sequence 5, 8, 11, 14, 17, 20, dot, 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 meaning it continues forever. If I ask you to find a sub 2, it means you're looking for what the term in the sequence is in the second position. So this is the first position, this is the second position, so a sub 2 would be equal to 8. The position and the actual term in the sequence in that position. So, if we understand that a sub n represents a term in the sequence, and we understand n is the position in the sequence, we should be able to look at any of these values in here and tell what n would be. So for the term 5, since we see it first, we know the value of n would be 1. If we're looking at 17 and I ask you what is the value of n, all you have to do is find the position in the sequence. So 17 is the first, second, third, fourth, fifth term, so n is 5. Knowing n, the value of n and the term in the sequence, we can use that to write formally, using n is 1 and that term is 5, we can say a sub 1 is 5, and all this signifies to us is the first term in the sequence a is 5. Putting it together in the same fashion, using n is 5 and that term, that respective fifth term is 17, we can say a sub 5 is 17. And all this means is the fifth term of the sequence A is 17. That's it. Now, if I asked you right now what is a sub 20, that would mean you would need to know the 20th term in the sequence, which we can actually find if we're tenacious enough. We realize first, second, third, fourth, fifth, sixth, and perhaps we see a pattern of how we get from one term to the next, 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 one term to the next. You can probably see that as we move along the sequence, we're constantly adding 3, adding 3, adding 3, adding 3, adding 3. So if we wanted to find a sub 20, it would be a little bit annoying right now to find it, but it would be possible. Later on, in the next few examples, I'm going to show you how we can find a sub 20 in a much easier way. So I'm not actually going to find it right now because there is a better way and I don't want to spend the time on it. However, if I asked you what does a sub 7 equal, this question I think you should be able to get without too much of a hassle. 1, 2, 3, 4, 5, 6. You know we're constantly adding 3. Yep, a sub 7 would be 23. That is correct. All right, more to follow.